Hello everyone. This is a video for discussing hexadecimal numbers. We previously discussed binary numbers and how you count and how they are generated. So this one is basically on hex, and we're going to discuss similar things. So in your text on page 15, you're going to see this table. This table obviously lists the three numbering systems we're working with. We're working with hex, we're working with decimal, and we're working with binary. If you recall, remember decimal is base 10, binary is base 2, hexadecimal is base 16. So the first question I want to answer is why base 16? Where did that come from? So to answer that, if you look at your binary column, there are 4 bits. 1, 2, 3, 4. All right? Remember, 4 bits are called a nibble. 2 nibbles are called a byte. So a byte has 8 bits, a nibble has 4 bits. You might need to know that because they're going to actually talk about that later on in the course. But anyway, if you see there's 4 bits, so the lowest value a nibble can hold is 0, if they're all 0. Now, the highest value a nibble can hold is in binary is if all the digits, are high or a 1, right? So this is 1 plus 2 plus 4 plus 8. That equals what? 15, right? So from 0 to 15, that holds 16 unique values. Remember, you have to count 0. So hexadecimal has 16 unique values. They start counting at 0 all the way to 9. Then they ran out of numbers. So now they have to start with something else. And what better thing to start with than the alphabet? So they started with capital A, B, C, D, E, and end with capital F. Okay? So this is your hexadecimal area, this is your decimal area, and then obviously this is your binary area. And the reason hexadecimal came about was due to this 4-bit limitation in binary. All right? So let's continue to the next. There we go. Now they talk about the counting rules. The counting rules for hex are basically what we're listed in the table. You start at 0. Next is 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you have to start at the letter A. Then B, C, D, E, and F. So the first rule here is count in sequence from 0 to F in the least significant digit. That's the rightmost digit, right? Now, once you've exhausted that, to count to the next one, you would do what? You would add 1 to the next digit to the left and set the least significant to 0, and you do it all over again. Come on, let's come over here. Here we are. Let's go and give it a shot here. So let's try this, right? We say we have 1. I'm starting at 1. We could actually start it. Let's just start at 0, 1, 0, shall we? And then we'll start at 1, 1. By the way, this is in hex. We're talking hex here. I want to make sure you understand that. Then what are we going to have? 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7. By the way, this isn't 16, this is not 17. It's 1, 6 hex, 1, 7 hex. And what do we have? 1, 8, 9, then what? 1A, 1B, 1C, 1D, 1E, 1F. Now what's the next number? I should make that a regular F there, right? What's the next number? It said when you have exhausted this, right, you've gone all the way to F, you're going to add 1 to the column to the left. So this 1 becomes a what? Becomes a 2, doesn't it? And then this one gets reset back to 0, doesn't it? And then if we take this all the way back up here, then what are we going to start with? We're going to go 2, 1, hex, 2, 2, hex, 2, 3, hex. And you just keep on going down, right? Till you're going to have what? 2F, hex. What's the next one? Well, you got to add 1 to this next column to the left, so this is going to be 3. The F is going to get reset to 0, right? Come up here, and you're going to restart it again. 3, 1, hex. 3, 2, hex. By the way, you can put a small h here if you like. When you see it in the literature, you're going to have an h there to represent hex. Because if you just saw, if I just wrote a number 1, 4, we assume it's decimal, right? The only way to know what numbering system you're talking about is to put the actual value. So you would see hex. Sometimes you're going to see this listed 1, 4, hex. It's going to be a capital H right up there. Sometimes you'll see it listed as subscript. All right, so that is how you basically count in hexadecimal. I think I'm getting rid of that now. Very good. Well, let's go back to the presentation. Now, let's try this problem. What is the next hexadecimal number after 999? So this is all in hex, right? So let's just write that down, shall we? So that if this is 9, I'm sorry, I gotta have this, I think I have to choose that one, right? See if that works. No, I don't like that one. Let's try that one, right? Here we go, 9, 9, 9, hex. All right, so what's the next number? Wouldn't you say, what comes after 9? A, doesn't it? Right? What's the next one? B, right? Hex. This is just, all these H's mean, it's just hex. That's all that's standing for. I just want you to understand that when you see that H, that's what it means. What about this one? I think the next problem was after 99F. That's a good question, right? So if you have a value of 99F in hex, right? So what's the first thing you're going to do, right? You're at your end of your rope here. There's no G in hex. It ends at F, right? So this is obviously going to be reset to 0. And you're going to have to add 1 here, right? What is 9? What's the next digit after 9? It's going to be A, isn't it? So you would start here at 9A0, hex. And then the next one is what? 9A1, hex. And then you would have what? 9A2, hex. And so on. All right? Let me see if there's another good question they have here. I'm trying to hit them all here for you. Oh, 9FF. Oh, that's beautiful. Let's do 9FF. This is rather exciting, I should say. So if we have 9F, F, and hex, right? And you want to, you know what? That's good. My penmanship is somewhat lacking, but I think you guys can follow it here. So let's look at this. So what comes after F? We know that's the final digit. It's 0, right? Well, if you add one here, if this goes to 0, you want to add one here, you've run out of space, right? So you're going to have to actually come over here and add it, right? So this will be 0. We know that. This is going to get reset to 0. What else happens? This is going to turn to A, isn't it? All right. Then A, 0, 1, hex. That should be a hex there. And so on. Let's just see how we did. Hexadecimal. The number is 999A. Is that what we did? 999A. We got that one, right? Let's see what the answer to the next one was. The number after 99F is what? 9A0. Is that what we got? 9A0. There it is, right? Now, what about the next one? The number after 9FF is A00. How did we do there? A00. We're on target. I think there's another one, isn't there? FFF. Well, so if you think of this, F, F, F. Doggone it. There we go. Hex. Don't try to pronounce that at home. That would be weird. But anyway, the next number, right? This is going to get reset to 0, right? This has to get reset to 0. This has to get reset to 0. One column over, right? One column this way. There's nothing there. But you can assume it's a 0, right? Well, you have to add 1 to it. It's going to be a 1. So there's your 1, 0, 0, 0. I'm sorry, there should be a little H there. Hex. And what's that one? 1, 0, 0, 0 hex. So there we go. All right? And I think there's one more I would like to go over with you here. List hexadecimal digits 190 to 200. All right? So if we're going to talk 190 to 200, let's try this one. 190 to 200, right? So I think it's going to keep the same size. Yeah, it does. Okay, good. So 190, let's just start counting. We just did this, right? I'm not going to write the H because we're going to assume everything is in H. Why don't I just write it up here, hex. Okay? So 190. The next one's going to be what? 191, 192, 193. I'm going to ... 198. You understand this is 194, 195, 196, 197, 198, 199. Now what's next? I can't hear you, but I assume you said 19A. And then what? 19B. 19C. 19D. 19E. 19F. What's after that? Well, you know, F is going to get reset to 0. You're already at the end of the chain there, right? So that gets reset to 0. 9, after 9 comes A, doesn't it? And you're going to have 1. So we're going to have 1A0, 1A1, 1A2, 1A3, ... all the way down to what? 1A What's next? What's next? Well, you're at AF, you know that's going to get reset to 0, the F will, right? Well, you're going to add 1 to the column to the left of it. What comes after A? B. There's your 1. And you're going to have 1, B, 1. 1, B, 2. You come all the way down here, and what are you going to have? You're going to have 1, B, F. And guess what? You're going to do the same thing over again, right? And you're going to continue doing this until you reach, you're going to go through 1C, 1D. Oh, wait a minute. You understand that there 1C0, 1C1, 1C2, 1C3. That's what's going on in here, right? And then you're going to go to 1D0, 1D1, 1D2, all the way up to 1DF. And then 1E. And then 1F, right? 1F0, 1F1, 1F2. And then finally, what comes next? You're basically going to have, at some point, right, you're going to have 1FF. When you add 1 to that, what's it going to be? Their final answer, this is going to reset to 0. This one's going to reset to 0. This one will, going to add 1 to it, it's going to be a 2. Alright, so there's how you count. Now let's see what they said here. They went from 190, 191, 192, all the way to 199A, 19A, B, C, D, E, F, just like we did. Then what did they do? They reset this to 0. They added 1 to the term to the left, so this 9 becomes A. It's 1, and they just continued it all the way up to 1AF. Then they did the same with B, C, D, E, 1FF into 200. I hope this has helped you understand hexadecimal and why it's used. It's important that you understand that this is a numbering system is going to be used later on. And since you're dealing with digital electronics, hexadecimal is used widely. All right. I hope this has been useful. Thank you very much.